In today's lesson, we'll be learning how to solve linear systems by elimination. This means that we want to find the point of intersection of two lines. There are three different ways of finding the point of intersection of two lines. You can do it graphically, you can do it with substitution, or you can do it with elimination. In our first example, we want to solve the linear system by elimination. You can see that there are two equations. Equation 1 is x plus y equals 8, and equation 2 is x minus y equals 11. In our first step, we want to stack equation 1 on top of equation 2 and then rearrange if like terms are not on top of each other. Let's start by rewriting equation 1. X plus y equals 8. I'm going to rewrite equation 2 directly beneath equation 1. X minus y equals 11. These two equations are now stacked on top of one another. We want to make sure that like terms are on top of each other. As you can see, positive x and positive x are on top of each other. Positive y and negative y are on top of each other, and positive 8 and positive 11 are also on top of each other. Therefore, we can go ahead to step 2. In step 2, we want to add or subtract equation 1 and equation 2 to eliminate a variable. We're going to need a little bit more space to do this. But let's rewrite what we had in step 1 first. X plus y equals 8 and x minus y equals 11. In the instructions, it says we can add or subtract these equations, so the choice is yours. However, we want to eliminate a variable. Therefore, there's only going to be one correct way of doing this. However, I'm going to show you both. Let's try adding these equations. When I do that, I'm going to put a line underneath these two equations, and I'm going to make a little note for myself that I'm adding equation 1 and equation 2 together. So, how do I do that exactly? Well, let's take a look at the like terms. I have x plus x. X plus x is 2x. Therefore, I'm going to write a 2x down here. Now, I have positive y plus negative y. Now, that is a little bit confusing because you have a positive and a negative sign together. When you have a positive and negative sign together, that becomes negative. So what you really have here is positive y subtract y, which is 0. Okay? Which means we've eliminated the variable of y, which is what we want to do. So I'm not going to write that 0 in. And last but not least, I have 8 plus 11. And that should be pretty simple. That is 19. Therefore, I'm going to put my 19 over here. At this point, we have 2x equals 19. Remember, we want to find x. But x is stuck with this 2. You need to ask yourself, what operation is going on here? When you have a number beside a variable and there's no sign, the operation is multiplication. So this is multiplied by 2. To get rid of multiply by 2, you need to divide both sides by 2. Therefore, I'm going to divide both sides by 2. These 2's cancel out because 2 divided by 2 is just 1. And we're left with x is equal to 19 divided by 2. And I'm going to change this into a decimal, which is 9.5. Now at this point, you could also try subtracting the two equations, but since we've already eliminated a variable and isolated a variable, therefore I think we can stop because we have x equals 9.5. In our third step, we want to substitute the variable from step 2 into equation 1 or 2, and then solve for the other variable. So you can start with either equation 1 or 2. The choice is yours. I'm going to use equation 1, which is x plus y equals 8. At this point, I'm going to substitute in my variable from step 2. So I'm going to say sub x equals 9.5. So instead of writing x, I'm going to replace it with 9.5. I'm going to put it in brackets. So 9.5 plus y equals 8. Now I don't really need the brackets, so I'm going to remove them. 9.5 plus y equals 8. Now we want to isolate y, but y is stuck with this 9.5. So what is the opposite of positive 9.5? Well, the opposite is negative 9.5. Therefore, I'm going to subtract that from both sides of the equation. Everything else stays the same. So I have 9.5 subtract 9.5. The plus y stays the same, and the 8 stays the same, but I'm adding a subtract 9.5 beside the 8 because I need to subtract 9.5 from both sides. 9.5 subtract 9.5, that cancels out, and you're left with y is equal to 8 subtract 9.5, which is equal to negative 1.5. Since I know the values of both x and y, I can write a concluding sentence. So let's go ahead and do that. I'm going to write, therefore, the point of intersection, POI, is 9.5 and negative 1.5. In our second example, we want to solve the linear system by elimination. Our first step is to stack the equations on top of each other and rearrange if like terms are not on top of each other. Well, let's double check this. So I'm going to rewrite equation 1, which is 2x plus 5y equals 30. And I'm going to rewrite my equation 2 right directly underneath it, which is 4x minus 5y equals 0. As you can see, my like terms of 2x and 4x are directly above one another, and my like terms of positive 5y and negative 5y are stacked on top of each other, and 30 and 0 are stacked on top of each other. Therefore, I can proceed to step number 2. In our second step, we want to add or subtract these equations to eliminate a variable and to isolate a variable. Let's go ahead and do that, but we need lots of space. Let's start with equation 1, which is 2x plus 5y equals 30. And let's rewrite equation 2 directly underneath, which is 4x minus 5y equals 0. Remember, you have a choice here. You can either add or subtract the equations. I'm going to try adding them first, and if that doesn't work, I'm going to subtract them. I'm going to make a little note for myself. I'm adding equation 1 to equation 2. Let's start with the first pair of like terms. I have 2x plus 4x. That is equal to 6x. So I'm going to write 6x down here. Now let's take a look at our other pair of like terms, which is positive 5y plus negative 5y. Now, when you have a positive and negative sign together, that becomes negative. So what we have here is positive 5y subtract 5y. And those two terms cancel out, so that becomes 0. I'm not going to write the 0 in, however. Now I'm going to look at my last set of like terms. I have 30 plus 0. That should be pretty simple. That's equal to 30. Therefore, I'm going to write equals 30 over here. Now, we want to isolate x, but x is stuck with this 6. And when you have a number beside a variable without an operation, it is multiplication. Now we have to think of the opposite operation and do that to both sides. Therefore, I'm going to have to divide both sides by 6. The 6's over here cancel out because 6 divided by 6 is just 1, and anything multiplied by 1 is itself. Therefore, I'm left with x is equal to 30 divided by 6. You should be able to do that, and that is equal to 5. Therefore, we've eliminated a variable, and we've isolated our variable of x. X is equal to 5. Therefore, we can proceed to the next set of steps. In step number 3, we want to substitute the variable from step 2 into equation 1 or 2, and then we want to solve for the other variable. Let's begin by choosing equation 1 or 2. The choice is yours. It doesn't matter. You'll get the same answer. So I'm going to start with equation 2 this time, just to change things up. I have 4x minus 5y equals 0. Now I'm going to make a little note for myself. I'm going to say sub x is equal to 5. And instead of writing the x, we are going to write 5 in brackets. Everything else stays the same. Let's simplify this a little bit. 4 times 5 is 20, and then everything else stays the same. At this point, we want to isolate y, but y is stuck with this negative 5, and it is also stuck with this 20. Let's get rid of the 20 first. If you look closely, this 20 is positive 20. The opposite of positive 20 is negative 20. Therefore, I want to subtract 20 from both sides of this equation. Everything else stays exactly the same. 20 subtract 20 is 0, so that effectively cancels out. What I'm left with is negative 5y is equal to 0 minus 20, and 0 minus 20 is just negative 20. Again, at this point, I want to get rid of this negative 5. When you have a number beside a variable, it's actually multiplication. So what I have here is multiply by negative 5. The opposite operation of this is divide by negative 5. I'm going to divide both sides by negative 5. These negative 5's cancel out, and all I'm left with is y equals negative 20 divided by negative 5. So 20 divided by 5 is 4, and a negative divided by a negative is positive. Therefore, y is equal to 4, and I'm in a position to write a concluding sentence. Since I know the values of x, which is 5, and the value of y, which is 4, I can say, therefore, the point of intersection is 5, 4. In our third example, we want to solve the linear system by elimination. In our first step, we want to stack these equations on top of each other. And we want to rearrange if like terms are not on top of each other. So let's rewrite equation 1, which is 3x plus 4y equals 22. And let's rewrite equation 2, which is 3x minus y equals 17. Again, you'll notice that 3x and 3x, which are like terms, are on top of each other. Positive 4y and negative y, which are like terms, are on top of each other. And positive 22 and positive 17 are also on top of each other, which means we can proceed to step 2. In our second step, we want to add or subtract these equations to eliminate a variable. So the choice is yours. You can either add or subtract. I'm going to continue to add, and I'm going to see what happens in this situation. Let's rewrite our equations. So I have 3x plus 4y equals 22. And I'm going to write my second equation, which is 3x minus y equals 17. Again, I'm going to make a little note that I am adding these two equations. So equation 1 plus equation 2. Let's go ahead and do the math on the side. I have 3x plus 3x, and that is equal to 6x. So I'm going to write 6x down here. Now, I'm going to look at positive 4y plus negative y. Now, when you have a positive and negative sign together, that simplifies into a negative sign. So what I have is actually positive 4y subtract y, which is positive 3y. So I'm going to put that over here. But as you know, you should be adding a positive sign here because it looks really weird if you have a 6x and a 3y beside each other without any sign. And last but not least, let's take a look at 22 plus 17, and that is equal to 39. So that is equal to 39. As you can see here, none of our variables was eliminated. We still have an x and we still have a y. We want to eliminate one of these, but adding these two equations did not accomplish that. Therefore, we're going to need to do the opposite. We're going to have to subtract these two equations. Therefore, let's repeat this entire process, but we're going to subtract them instead. So let's rewrite equation 1, which is 3x plus 4y equals 22. And our second equation, which is 3x minus y equals 17. So I'm going to make a little note to myself that I am subtracting equation 2 from equation 1. Let's write the work on the side. 3x subtract 3x is 0. I'm not going to write that 0 in. Now let's work with positive 4y subtract negative y. When you have two negative signs together, that becomes a positive. Therefore, you have positive 4y plus y, which is positive 5y. I'm going to write that over here. Last but not least, I have 22 subtract 17, and that is equal to 5. So I have 5y equals 5. I've eliminated the variable of x, so this is a good thing. Now I want to isolate y, but y is stuck with this positive 5. When you have a number beside a variable without any sign, that means it is multiplication. To get rid of it, we need to do the opposite. So we need to divide both sides by 5. Therefore, I'm going to divide both sides by 5. The 5's cancel out because anything divided by itself is 1, and anything multiplied by 1 is itself. So I have y is equal to 5 divided by 5, which is 1. Therefore, I've successfully eliminated the variable of x, and I've isolated the variable of y. And I am good to start the next two steps. In our third step, we want to substitute the variable from step 2 into either equation 1 or 2, and then we want to solve for the other variable. Let's start by selecting an equation. It doesn't matter which one you choose, but I'm going to choose equation 1 in this situation. So I have 3x plus 4y equals 22. I'm going to write myself some instructions. I'm going to substitute in y equals 1. That is what I figured out in our last step. So instead of writing y, you're going to write 1 in brackets. And everything else stays the same. So the 3x stays the same. Positive 4 multiplied by 1 is positive 4. And then the 22 stays the same. Remember, you want to isolate x, but x is stuck with this 3 and it's stuck with this positive 4. Let's get rid of the positive 4 first. So the opposite of positive 4 is subtract 4. Therefore, I'm going to subtract 4 from both sides of the equation. So I have 3x plus 4, subtract 4, and then I have 22 subtract 4. As you can see, positive 4 subtract 4 cancels out, which leaves me 3x. Now 22 subtract 4 is 18. Now, I want to isolate x, but x is stuck with this 3. When you have a number beside a variable with no operation, the operation is multiplication. So what is the opposite of multiplication? The opposite is division. So we're going to divide both sides by 3. When you do that, the 3's cancel out, which leaves you x, and then 18 divided by 3 is 6. Therefore, we have enough information to write a concluding sentence because we figured out what y is equal to and we figured out what x is equal to. So I'm going to write, therefore, the point of intersection is 6, 1.